Welcome to today's class. So let's solve these questions using integration by substitution method. In the first question, we are asked to evaluate cos x all over 5 plus sin x all squared and then dx. So let's call this equation 1. Our first task is to identify u, and most times u is the most complex term. So let u be equal to 5 plus sin x. The most complex term here is 5 plus sin x squared. So let u be equal to 5 plus sin x. So if you differentiate u with respect to x, you would have cos x. So if we cross multiply, we would have du equals cos x dx. Now let's make dx the subject formula. We have dx becomes du all over cos x. So our next task is to substitute into equation 1. This is equation 1. Cos x all over 5 plus sin x all squared dx. So this is equation 1. So if we substitute into equation 1, we would have integral of cos x all over u squared multiplied by du all over cos x, because dx gave us du all over cos x, and then we took u to be equal to 5 plus sin x. That's why we have u squared here. Now cos x cancels cos x. We are left with integral of 1 all over u squared multiplied by du. From the law of indices, this can also be written as u raised to the power negative 2 du. If you've not watched my video on indices, kindly check the description below and you will see the link to indices. So if we integrate, we would have, if we integrate u raised to the power negative 2, you would have u raised to the power negative 2 plus 1 all over negative 2 plus 1. Remember, in integration, you add 1 to the power and then divide by the power plus 1. So this gives us u raised to the power negative 1 all over negative 1. So here we have negative u raised to the power negative 1. This can also be written as negative 1 all over u. Now our next task is to substitute the value of u. So if we substitute the value of u, we would have negative 1 all over 5 plus sin x, and then plus integration constant, which is c. So this is our final answer. Now let's solve the second question. We are asked to evaluate sin 6x and then cos x dx. Sin 6x can also be written as sine x raised to power 6. So let's rewrite the question. So we have sine x raised to power 6 multiplied by cos x dx. Now let's call this equation 1. Now our next task is to identify u. As I earlier said, u is always the most complex term. So let u be equal to sine x. Therefore, du all over dx equals, if you differentiate u with respect to x, it would give you cos x. Now our next task is to cross multiply. So if we cross multiply, we would have du equals cos x dx. So let's make dx the subject formula. We have dx equals du all over cos x. So our next task is to substitute the necessary parameters into equation 1. So if we substitute into equation 1, we would have integral of u raised to power 6 multiplied by cos x multiplied by du all over cos x. So cos x cancels cos x. We are left with integral of u raised to power 6 and then du. Now if we integrate u raised to power 6 with respect to u, we would have u raised to power 6 plus 1 all over 6 plus 1. Remember, in integration, you add 1 to the power and then divide by the power plus 1. So we have u raised to power 7 all over 7 and then plus c. So our next task is to substitute the value of u. So if we substitute the value of u, we would have sine x all raised to power 7 divided by 7 and then plus c. This can also be written as sine 7x all over 7 plus c. So this is our final answer.